Data security is a critical aspect of data engineering, as it involves the collection, storage, processing, and transmission of sensitive and valuable information. Ensuring data security is essential to protect an organization's assets, maintain regulatory compliance, and build trust with customers and partners. Here are some key considerations for data security in data engineering. Access control. Implement strict access controls to ensure that only authorized individuals or systems can access and modify data. Use role-based access control, RBAC, to define and enforce who can perform specific actions on data. Authentication and authorization requires strong authentication mechanisms such as multi-factor authentication, MFA, to verify the identity of users and systems. Additionally, implement authorization policies to define what actions each authenticated user or system is allowed to perform. Encryption. Encrypt data at rest and in transit. Use encryption algorithms and protocols like TLS-SSL for data in transit and encryption solutions such as AES for data at rest. This prevents unauthorized access to data even if a breach occurs. Data masking and anonymization. When dealing with sensitive data, consider using data masking and anonymization techniques to replace sensitive information with fictional or masked data while preserving data integrity for testing or development purposes. Secure data transfer. Ensure that data transferred between systems or over networks is done securely. Employ secure file transfer protocols, example SFTP, SCP, and use encryption to protect data during transit. Data classification. Classify data based on its sensitivity. Not all data is equally valuable or sensitive, so prioritize security measures based on the classification of data. Data retention and disposal. Establish clear data retention policies and procedures. Dispose of data that is no longer needed, and do so securely to prevent data leaks. Audit trails and logging. Implement comprehensive logging and auditing mechanisms to track data access and changes. Regularly review logs for suspicious activities and maintain audit trails for compliance purposes. Vulnerability scanning and patch management. Regularly scan systems and applications for vulnerabilities and apply patches and updates promptly to address security flaws. Firewalls and intrusion detection systems. IDs employ firewalls to control network traffic and intrusion detection systems to monitor for suspicious activities. These tools can help detect and respond to security threats in real time. Secure coding practices. Encourage secure coding practices among data engineers and developers to prevent common security vulnerabilities, such as SQL injection or cross-site scripting, XSS, in data pipelines and applications. Data privacy compliance. Comply with data privacy regulations and standards such as GDPR, HIPAA, or CCPA, depending on the nature of the data you handle. Ensure that data engineering processes align with the requirements of these regulations. Incident response plan. Develop an incident response plan to address security breaches or data leaks promptly. This plan should include steps for containment, investigation, notification, and recovery. Security training and awareness. Educate data engineering teams about data security best practices and raise awareness about potential security threats and social engineering tactics. Regular security audits. Conduct regular security audits and assessments to evaluate the effectiveness of your data security measures and identify areas that require improvement. Data security should be an ongoing process, with continuous monitoring and adaptation to evolving threats. It's crucial to strike a balance between data accessibility and security, ensuring that the right people have access to the right data at the right time while protecting sensitive information from unauthorized access or breaches.